Okay, Weir overflow rate. Similar to surface overflow rate, but this time instead of calculating surface area, in this problem with a circular clarifier, we need to calculate the circumference because in this problem we're assuming water is flowing over to the weirs at the outside edge. So for a Weir overflow problem, Weir overflow rate, always going to be asking you for gallons per day per foot. And see if I can move this down a little bit so you can actually read the question. Gallons per day per foot, so it's linear feet. Circular clarifier, it's going to be the circumference of a circle. In a rectangular clarifier, typically you're going to have weirs at one end, so it may be the width of the tank, or for example, our rectangular clarifiers at our plant in Perrysburg, the weirs actually look like this. There's a baffle at the end, like a wooden plank that sticks up over the surface of the water, and then on the other side there are rectangular weirs. Like so. If I drew a picture of it, it would look like this. There's a channel with a rectangle in the middle, and the flow comes up through the rectangle and over the sides. So that's actually creates more feet of weir for the flow to go over than if it was just a straight length or straight width of the tank. But in a situation like that, they probably are just going to give you the length of weir in feet rather than have you calculate it. But let's go ahead and calculate it for our example problem here. So we need to know what the formula is for the circumference of a circle. I apologize, I don't have my formula sheet out. I'm trying to do math problems with one eye and watch a high school football game out of the corner of my other eye. Circumference of a circle, I believe, is 2 times pi times radius, 2 pi r. So yes, 2 times pi times radius to calculate the circumference. So in our problem, since the radius 70-foot diameter tank, radius is 35 feet, it's going to be 2 times pi times the radius of 35 feet gives us the circumference. Which is 219.8 feet, which we're just going to round up to 219 feet. And then we need to calculate gallons per day per foot. So we have the feet of weir, and they give us the gallons per day right here, 3.5 million gallons per day, or 3,500,000 gallons. So 3,500,000 gallons per day divided by, oh, I guess I should have rounded that up to 220. Whoops, sorry about that. We'll say 220 feet of weir, 220 feet equals 15,909 gallons per day per foot. So gallons per day per foot for Weir overflow rate, gallons per day per square foot for surface overflow rate. I promise you, on a multiple choice math question, they are going to give you an opportunity to mess this up by calculating gallons per day per square feet. So one of your choices would probably be 15,910 gallons per day per foot, and then they will give you an opportunity to calculate the surface overflow rate of, let's say, theoretically, I'm not going to work this out, but let's say 220 gallons per day per foot, so that if you accidentally use the wrong formula, you're going to get an answer that looks right. So pay attention. Weir overflow rate, and as I mentioned it with the last question, they always tell you how to do the problem with these, which is kind of nice. It makes them kind of easy. Gallons per day per foot. So that's surface overflow rate.